going to look at Archimedes today, which is part of the fluid systems topic. So it's all based around this principle. Now, if you've done anything on Archimedes before, it's probably the idea of how he calculated the volume of an irregularly shaped object. So it's the story about the king's crown, and he worked out that if you place the crown in water, the exact amount of water that came out would give you the volume of the volume of the water would equal the volume of the crown. And he worked out when he got into a bath that was full to the top. Anyway, so Archimedes' principle, it goes a little bit beyond just calculating density, but it gives us a way to calculate the density of an object or the weight of an object when placed into a liquid. You can read this principle here, but it's more easily summed up in a way that you would have seen from the video from last lesson. So if you haven't seen the video from last lesson, it's really good. Go on to class charts and get the link, and the guy explains it far better than I will. Okay, so if you put an object in water, it feels lighter. That's what this says. So by how much does it feel lighter? So let's say it felt like 5 kilograms. You put it in the water, it now feels like 3 kilograms. So that's its loss in weight, or its loss in mass, really. I'm talking in kilograms, all right? So that'll be equal to the mass of the water. So you place an object in water that's completely submerged, or here it's not completely submerged, it's floating. So these are the two things that we'll come across today: totally submerged or floating. So here we go. This is the guy from last lesson, and he's given us upwald. So this is summarizes Archimedes' law quite nicely. The upward force is the up part of it, and wald is weight of liquid displaced. I'll try and explain that with some examples in a second. Now, the other formula that you need is density equals mass of volume, which can be rearranged, as you can see there. Now, you did that in year 10, and yeah, you'll definitely use that here. Okay, so here we have a visualization of Archimedes' principle. You've got a 5 kilogram mass. It's placed into water. It now feels lighter. It's only 3 kilograms. So it's displaced a certain amount of water. This is like a Eureka can. So that water fell out to the right. And you can see in the bottom right, there are 2 kilograms of water sitting there. So it feels 2 kilograms lighter. And the weight of the water displaced is 2 kilograms. Upward, the upward force, well, it did have a downward force of 5, and it still has. Gravity's still pulling it by 5, but it only feels 3. So there must be an upward force of 2 to balance that out. So the upward force, 2 kilograms, equals wald, weight of liquid displaced. So the weight of the liquid displaced, if you weighed that liquid there, or mass of liquid displaced in kilograms, would be 2 kilograms. Here's an object floating, top left. So whatever that weighs, whatever that block in the water weighs, or let's say whatever its mass is in kilograms, will be equal to the mass of the liquid that it's displaced. But it's not a Eureka can, is it? There's no water that's fell out. So how would you know how much liquid it's displaced? Well, that we go back to the original work that Archimedes did. You could just work out the volume of the object that's underwater. So not the whole volume of the block, but just start it here and that volume of the block, and that will give you the volume of the water, and then you can work out the mass of the water from that. So when you're talking about the amount of water displaced or the mass of water displaced, it explains how a boat can float. It explains if you put more people onto a boat, as in here on the right, the far right, it will sink lower into the water, and that's because it needs to displace more water to have a greater upthrust to ensure they can still float. And here's 2 steel objects that have the exact same mass, but by changing the shape of it, you displace more water, so you can float. You have a greater upward force and therefore float. So here's the question for today. I will talk you through it, and you just need to send me your workings plus the answer. So hopefully this will make sense to you. But I do want you to take the time to set it out nicely, please. Make sure you've got. I would try and encourage you to, when you see a question that's clearly about Archimedes' law, they all look very similar. Just start by writing upwald, and then remind yourself of density equals mass divided by volume. Okay, so it's asking you to calculate the density and the mass of the wood. So we have an object that's floating, the wood is floating, and it's partially submerged. So it has a height of 0.2 meters and only 0.15 meters of it are underwater. So I'd write upward, the upward force, which is its weight or its mass, because it's floating, so that's the up thrust has to equal the weight. So upward force equals the weight of the liquid displaced. So if I can get the weight of the liquid that's being displaced, I can get the upward force. And the upward force, we know, equals the weight of the block. So I'll have the weight or the mass of the block. So let's get the mass of the liquid that's being displaced. So to do that, it's always going to be linked to this formula bottom right. I want to get mass of the liquid displaced. So it's going to be density multiplied by volume. Have I got the density of the liquid? It's here, 1,020. Now, pure water will have a density of 1,000. So seawater with impurities in, with salt in, will have a slightly larger density. So that's my density, but I need to multiply it by the volume. Well, it's the volume of the liquid displaced. So there, you need to think back to Archimedes and the bath, and that's the volume of the amount of the wood that's under the water. So the dimensions of the wood that's underwater will be equal to 0.5 multiplied by 0.3, which is the width there, and the depth of it is 1.8. So 1.8 multiplied by 0.3 multiplied by 0.15 will give me the volume of the wood that's underwater, and that's equal to the volume of the water that's displaced. So that calculation gives you the volume of the water displaced. I now have volume, and multiplied by density, I will have the mass of the water displaced. Density is up here, so you should now be able to get the mass of the water that has been displaced. Now, this is where upwald comes in, and the Archimedes law. Now you have the mass of the liquid that's been displaced, the water that's been displaced. That's equal to the mass of the object, because it's floating. If it wasn't floating, it wouldn't be equal to the mass of the object, it would be equal to the loss in mass of the object. But here, because it's floating, its loss in mass is all of its mass. So when you calculated the mass of the liquid that's been displaced, that also gave you the mass of the wood. So the two values are equal. So now you have mass, and then you ask for density of the wood. And the big mistake here would, okay, mass and density. I have mass and, sorry, I'm after density. So I have mass, and then if you get volume, you can get your density. The big mistake people often make is they use the same volume you just calculated, and then that'll give you the same density. It will give you the block a density of 1,020, which can't be right. So remember, the dimensions of the wood will be different. It will have the same depth and width, 0.3 and 1.8, but its height will be 0.2, because we're now talking about the whole of the block. So that will give you the volume of the block, 0.2 times 1.8 times 0.3. You know the mass of the block, equal to the mass of the liquid displaced. So knowing the mass and knowing the volume, you can get the density of the block. The units of density are up there, kilograms per meter cubed. Yeah, easy units to remember, really, because if you can picture a cubic meter, like a massive fish tank, then that would have a mass of 1,000 kilograms if it was pure water. So kilograms per meter cubed. So then that should give you the density of the wood. So what I'd like to see is you setting this out really nicely, have Upwald at the top and density equals mass of volume at the top. I would say part one is get the weight, or sorry, the mass of the liquid displaced. It's part one, that's the right-hand side of Upwald, that's the Wald. Then a second statement saying that's equal to the mass of the block because it's floating. And then the third part would be calculating the density of the block using density formula. Okay, so if you can send me that working, that would be great. Now, if this is not your preferred way of learning and watching this video, a couple of times and you're still not taking it in, do try and pause it and make notes as you go through. But yeah, if you're still struggling with it, email me. I'll help you out. I'll show you how it's done. I'll write it down for you, and I'll scan you a copy of my workings. But otherwise, I'll just check that your solution is right. And the key thing about this is getting in the right habit. Don't start a question on Archimedes' law without writing Upwald and writing density equals mass of volume. Okay, I hope that helps. And I will, next lesson we'll look at a few more problems, but they're all very, very similar. Okay, thank you.